Hello students, welcome back to my YouTube channel. In this video we are going to discuss about operational amplifiers, which is part of linear integrated circuits. In this video we will discuss characteristics of ideal op amps, difference between ideal op amps and practical op amps, what is open loop operation of op amp. First of all, why do we call this operational amplifier as operational? Why the term is used? Why this term is used? In olden days, scientists used to do mathematical operations such as addition, subtraction, comparison, and so other things with the help of these amplifiers. From there, that name operational amplifier has come. Now let us see what is ideal operational amplifier. In ideal op amp, these are the characteristics. Ideal op amp characteristics are open loop gain is infinite, means there can be two outputs. One is finite output, one is infinite output. In case of finite output, let us take this is ideal amplifier, ideal op amp. You are getting 1 volt as output. If it is ideal op amp which is operating in open loop mode, then input must be 0. Input means what? V2 minus V1 is the input. And if it is infinite output, then input must be finite. In this case also, open loop gain of operational amplifier will be infinite. This is one thing. Second thing is input impedance Ri is equal to infinite, means this value is infinite for an ideal op amp. What happens if it is infinite? It won't draw any current from the source. Our operational amplifier will not draw any current from source. What it indicates? If we connect our operational amplifier to any device, any preceding device, then because of this operational amplifier, the characteristics of preceding device will not change. That is the advantage of input impedance, high input impedance device. And one more thing, if we connect any 2-3 device in cascading, and all these are op amps with input impedance infinite, then what happens? This preceding device will not change the behavior of this operational amplifier. This device will not change the functioning of this operational amplifier. If the input impedance is high, you can connect any number of devices in cascading, and output impedance R0 is equal to 0. What does it indicates? Means if it is 0, we know in case of any transformers, we know the concept of voltage regulation. Output, if the transformer impedance will affect output voltage of the transformer. But in this case, if R0 output impedance is equal to 0, means this P0 output voltage purely depending upon open loop gain and given the input voltage, differential voltage. It won't depend on resistance of the output circuit. Why? Because it is 0, and output load current is output voltage is only dependent on output load current. That load current will not be changed with the changing of this output resistance. That is the reason one operational amplifier you can connect any number of devices. This output voltage will not change because of this output resistance. It is just like similar to voltage regulation concept in transformers. Their output voltage changes with respect to the change in impedance of the transformer. Here, as the impedance is 0, output voltage will not change, and this allows us to connect as many number of loads to the output. And bandwidth is 0. Bandwidth means 0 means what we call bandwidth, a signal which is having 0 frequency to higher frequencies, infinite frequencies. Let us take 0 to infinite frequency. Your operational amplifier will accept all kind of the signals you can give as input. And zero offset means what? When V1 is equal to 0, V2 is equal to 0, ideally what should happen? What should happen means V1 is equal to 0 and V2 is equal to 0 means V0 is equal to also 0. Practically it won't happen. Practically if you take any practical operational amplifier, even if you keep V1 equal to 0, V2 is equal to 0, there will be some voltage output you can measure in the output terminal. That is called zero offset. For an ideal amplifier, it is 0, means it perfectly operates. When no voltage is given as input, there will not be any output voltage. And let us see what is the difference between ideal operational amplifier and practical operational amplifier. In ideal operational amplifier, open loop gain is infinite. In practical operational amplifier, open loop gain is very large, but it is finite. It is measurable with the available measuring devices. In ideal operational amplifier, it is infinite, which you cannot measure. Input impedance of the ideal operational amplifier is equal to infinity, whereas practical operational amplifier, it is high, but you can measure. Output impedance, as I said earlier, output impedance is 0, but in practical operational amplifier, there will be output impedance. It is low, but it is not 0. Bandwidth means it can accept various range of signals, various range of frequencies. Here, for practical operational amplifier, it cannot accept all the signals. Depending on type of operational amplifier, it may block some range of signals and it may allow another range of signals. And zero offset, as I said earlier, when V1 is equal to V2 is equal to 0, output is equal to 0. Here, even though V1 is equal to 0, V2 is equal to 0, out not equal to 0. These reasons we will discuss in coming videos. This is very important part for interviews and this GATE exam. We know output equation is V0 is equal to open loop gain into V1 minus V2. Here V1 generally you take positive voltage applied across the positive terminal. V2 is voltage applied across the negative terminal. And V1 minus V2 is the differential input voltage. Our operational amplifier, what it does means, it takes the differential voltage of the input and it will amplify to the value which is multiplied by open loop gain. In what happens if we give, what happens in a operational amplifier in open loop mode? Here open loop mode means there is no connection. There is no connection from output to input. There is no feedback is being given from output to input. That is why we call it as open loop configuration of operational amplifier. Here what happens, it simply acts as a switch, means if positive voltage is higher than negative voltage, output will be positive side. Here we use term as V saturation positive. Generally V saturation means what is the there are two supply voltage, one is plus VCC, another one is minus VCC. V saturation means this V saturation is almost equal to VCC, means supply voltage of positive terminal. And if voltage at the positive terminal is less than voltage at the negative terminal, the output will go to negative saturated voltage, means minus VCC. Here you may get question like this. Assume that you are operating your operational amplifier in open loop mode and you give sinusoidal voltage. What will be the output voltage you get? This may be interview question. You may be asked in any interviews. Means whenever this is nothing but input voltage, means here you see input voltage to this particular operational amplifier. What we have done here, negative terminal we grounded, we are giving voltage to positive terminal, means V1 minus V2, V1 is sinusoidal, V2 is equal to 0, so you are giving only sinusoidal. What happens, sinusoidal up to from this 0 to 180 degrees it is positive. You take any instant voltage, it is positive. So what happens in operational amplifier, the output will be positive saturation voltage. Whenever it crosses 0 and it goes negative side, the output will be minus Vsat. Like this you will get this waveform. You see, in case of ideal operational amplifier, it will be perfectly squared. This question you may be asked. This is simply when V1 is at positive terminal, voltage is higher than negative terminal, you will get positive saturation voltage, vice versa. And what are the some applications of operational amplifier in open loop mode? Comparators, they compare two voltages and produce high or low output, just like what we discussed. Let us take this is positive, negative. V1 voltage you give V2 voltage. V1 is greater than V2, you will get high, or if this is greater than V1, you will get low. Like this they use it in many applications as comparators. Detectors detects when input crosses a reference voltage. This also we will discuss in upcoming videos. Output limiters and A to D, D to A converters. In next video we will discuss about importance of feedback in operational amplifier, what is inverting amplifier, what is non-inverting amplifier. We will solve some previous gate questions. We will also discuss some sample interview questions. Thank you. Like, subscribe and share the video. Thank you.